So friends, we are going to learn about the difference of distance and displacement. It's a very simple topic and the basic topic of mechanics. Now listen, to understand that, let us take a situation. But Mr. X is living somewhere here and he want to go to his school. That is his school. Now the road from his home to school is very long. So Mr. X starts moving. He starts moving from point A to B, and then B to C, and then C to D, and then D to E, and E to F, and then finally at his school. So this is the way he travels from his home to school. Now if I want to find the distance covered or the path length covered by Mr. X from home to school, so it is very easy, because you just need to sum all the distances he covered in way to home to school. Let us take it simple. Listen, if you add AB plus BC plus CD plus DE plus EF plus FG, that will give you the distance covered by Mr. X. So it's the whole length of the path. So that is called path length or the distance. But if you want to measure the displacement, then what we need to do? We need to measure the direct distance between point A and point G. If I want to measure the displacement between home and school, so I just need to draw a straight line from A to G. Then I need to measure it directly. Whatever the length of this straight line, that will give me the displacement. So friends, you can understand that here the distance is the total path length. Let us suppose the distance is D and the displacement is from A to G, a minimum possible distance, or you can say it's a direct distance. So in most of the cases, if I just denote the displacement by X, then distance will be greater than displacement, because the distance is the total length of the path, which obviously greater than AG, the direct length. But if I just say you that I want to measure the distance covered between C and D and the displacement between C and D, so you can see that your object is traveling on a straight path between C and D. So what will actually happen? Whatever you will get the distance, you will get the same displacement. So in that case, the distance and displacement will be same. So my friends, if your object is traveling on a straight path or the straight road, the displacement and the distance covered by the object will be same. So in a special case, the distance will be equal to X. So the relation between distance and displacement is what? It's greater than or equal to displacement. So if I take displacement in the denominator, I will get D by X will be greater than or equal to 1. So the ratio of this distance to the displacement is always greater than or equal to 1. So this is it, friend. It's very simple topic. I hope you can understand. So friends, this is distance and displacement on a straight line. Let us discuss that a straight line is having only two directions. So one of the direction we need to take positive and the other direction we need to take negative. As I have taken x-axis as my straight line and we are discussing one-dimensional mechanics, so the object will able to move on just one dimension. And as I said, one dimension will have two different directions, positive and negative. So this is my reference point O, you can see that, and the right hand side of that reference point is taken positive and the left one is taken negative. So here I have taken 10, 20, 30, 40, 50, 60, 70, 80. All those distances or the displacements are positive and the left hand side is taken negative. Those distances are in meter. So let us take a situation that my Mr. X is living somewhere on point E and his friend, his very good friend Mr. Y, is living on point K. So here there are two friends living at different places. So this is E, which is 50 meter. You can see that is the initial position of Mr. X, and K, which is minus 30 meter, is the initial position of Mr. Y. Now Mr. X wants to meet Mr. Y, so he started moving from E to K. So he moved from E to K and met his friend Mr. Y. So let us talk about the distance and the displacement covered by Mr. X. As you can see, Mr. X moved from E to K. So in case of distance, we need to just add the numbers or add the distances, because distance is a scalar physical quantity, so we don't need to take the negative values. So what happened? Mr. X moved from E to K. So let us add the distances from 50 to 40, 10, 20, 30, 40, 50, 60, 70 and 80. So the distance covered by Mr. X is 80 meter. It is very simple. Let us do it again. So Mr. X moved from E to O, and that is 50, and then O to K, that is 30. So 50 plus 30, that will be 80 meter. Now the displacement on a straight line is denoted by delta x, and delta x is xf minus xi. xf is called the final position. As Mr. X is on K finally, then its final position is minus 30. So I will write minus 30 is the final position. xi is called the initial position. Mr. X was on E. So the initial position of Mr. X is 50, so minus sign as it is, and then xi is positive 50. So minus 30 minus 50, you will get negative 80 meter. So the displacement of Mr. X is negative 80 meter. Now you can see that the distance is positive 80, but the displacement is negative 80. Because Mr. X moved, or the displaced, he displaced from E to K, which is in negative direction. That's why the displacement is negative. But the distance is always positive, as we can see. So his wife, Mrs. X, is worried. He is at E, at their home. So she is worried that, where is Mr. X? So she started wondering. Normally what happened, Mr. X always used to go at H. Suppose the H is a sea beach. So he used to go at H. So Mrs. X just thought about, let us do a search at H. So she just went to H instead of K. So she is here at H. Now you can see that just she moved from E to H. So let us talk about the displacement or the distance of Mrs. X. Let us do it here. So Mrs. X moved from E to H. So here it is, E to H. The distance D from E to H, it is 50 to 60, 10, then 60 to 70, 10, so 20 and then 30. So the distance covered by Mrs. X is 30 meter. The displacement delta x is what? The final position minus initial position. So the final position of Mrs. X is 80 minus the initial position of Mrs. X was 50. So it's minus 50. So you can say that the displacement is positive here, 30 meter. Because Mrs. X moved from E to H, which is in positive direction, so we are getting the displacement positive number. Now Mr. X realized that he forgot to tell Mrs. X, so he is also worried. So he started moving from K to E. So he came back to his home. So he is here. Now he moved from K to E. If we think about the whole path covered by Mr. X, he initially moved from E to K and then moved from K to E. So what will actually happen? The idea of displacement will be E to K and then finally E. The distance covered by Mr. X is what? E to K, we know it is 80, and then K to E, that also be 80 because they will be same. So here 80 plus 80, it's 160 meter, the distance covered by Mr. X. But the displacement delta x, which is xf minus xi. So the final position of Mr. X is 50. It is E. The final position is E, which is 50 meter. And the initial position was also E. So it was also 50. So if I do 50 minus 50, you will get 0. So you can see that if object comes back at the original position, then its displacement becomes 0. Now Mr. X worried about his wife, Mrs. X. She is not home. So he started wondering that I think she will be at their used to or the regular position, which is H. So he went to H following Mrs. X. So here they are. So let us discuss the total displacement of Mr. X. So Mr. X started from E, you know it, then he moved to K, then again he came back to E, and then he went to H. So if I talk about distance, I know the distance from E to K to E because this is it. So D is equal to 160 up to here. Then I will add 170, 180 and 190. So the distance covered by Mr. X in the total journey is 190 meter. But the displacement, E is the initial position and H is the final position. So delta X, which is final minus initial, so final is H, which is 80, minus initial, which is E, that is 50. So the displacement of Mr. X is 30 meter. In all these cases, you are seeing that the displacement is always less than or equal to. In some of the cases, it is equivalent. Here you can see they are equal. The distance is always greater than or equal to displacement. So that is the main thing you need to understand. Whenever object moving on a straight path, these are the ways to find distance and displacement. Friends, I want to discuss with you the idea of distance and displacement on a circular path. But to understand that, we will need to understand two different things, which is already the basic knowledge whenever you want to learn the distance and displacement on a circular path. The first thing we need to understand is Pythagoras Theorem. I think all of you know that in a right angle triangle like this PQR, where Q is the right angle, if the side lengths are A, B and C, so Pythagoras said that A square plus B square is equivalent to C square. So the addition of the square of these two sides are equivalent to the square of the hypotenuse. So from this theorem you can find any of the side given. Let me take an example. Suppose if I am having a triangle which is R, R, and I want to find the hypotenuse. So what will be that? Let us suppose the hypotenuse is X. So I will write X square is equal to R square plus R square. So that will be 2 R square, which is equal to X square. As I want to find X, that will be root 2 R. I just taken the square root. This is very simple. So this is the idea how you can find any of the side given. Let us do another problem. Suppose in a triangle, this is 13, this is 5, I want to find this side. So what? The square of 5, let us suppose this is X, square of X, which will be equivalent to square of 13. Now square of 5 is 25 plus X square, which is 169. So X square, that will be 169 minus 25, and that is equivalent to 144. So if you take square root both the side, we will get X is equal to 12. So this side will be 12. This side will be 12. Sorry. So this is Pythagoras theorem. I think it is very simple to understand. We are going to use this idea whenever we will discuss the distance and displacement concept on a circular path. Second topic which is useful to find distance and displacement on a circular path is length of an arc. Now the length of an arc is a problem or is an issue which you already learn. Now I just want to revise it. Let us do it. I am having an arc which is AB. Now you all know that this arc is a part of a circle, is a small fragment of a circular track. Now these are my radius and O is the center of that circle which the arc of is a part. So the R is the radius and the angle at the center made by arc is theta. Now let us discuss first about the angle. The angle can have two different units. The first we normally use is called degree. We say 30 degree, 60 degree, all those kind of things. The second unit of the angle is called radian. Now you can convert the degree into radian or radian into degree. Suppose I am having theta is 60 degree and I want to convert it in radian. So what I will do, I will multiply 60 degree by pi upon 180. So what, 60 3s are 180 and I will get pi by 3. This is called radian. So 60 degree is equivalent to pi by 3 radian. Let us do another problem. Suppose theta is 135 degree and I want to convert it in radian. So what will happen? It is 135 multiplied by pi by 180, and that is 135 is just 45 3s and this is 45 4s. So we will get 3 pi by 4 radian. So 3 pi by 4 radian is equivalent to 135 degree. Here phi is 3.14 that you all know. So these are the two units and this is the conversion phenomenon. You can convert the radian into degree also, but you just need to multiply it by 180 by pi. Okay, why am I saying this? Because the formula of the length of the arc is pi r theta divided by 180. Now we need to understand here the theta is in degree. We just multiplied it by pi by 180 to just convert that theta into radian. So what I will say, this pi by 180 and theta both are just giving me the angle, and that angle is in radian. Understood? And that is multiplied by r, which is the radius. So this is called length of the arc. So we need to take, or we need to adapt a formula which is the length of the arc, which is angle multiplied by radius, and that formula we are going to use in the distance and displacement on a circular track. So friends, let us learn about the distance and displacement on a circular path. This is a circular track I have selected. The track is A, B, C, D and A. The track is having radius r and my Mr. X is moving on the track. Initially, suppose he started moving from A to B. So he moved from point A to point B. And I want to find the distance covered by Mr. X and the displacement by Mr. X. So let us do that. To find the distance covered between A and B, the distance is the total length of the path covered. Now this path is having shape like an arc because it's a part of a circle, so it will be an arc. Now we know the formula of arc. Arc is equal to angle multiplied by the radius. Let us suppose the angle covered by Mr. X is theta from A to B. You can see the angle trace at the center is 90 degree when Mr. X moved from A to B. So I will take 90 degree. But my friends, we cannot take the angle directly in degree, so we need to convert it in radian. To convert the degree in radian, we need to multiply it by pi by 180 as we know. Then multiply it by the radius as in the formula. So 90 2s are 180, we will get pi by 2 into r, that is the distance covered by Mr. X during A to B. If I substitute the value of pi and r, let us suppose the pi is 3.14. So 3.14 divided by 2 is 1.57. And if I take the radius is 1 meter, then the distance covered by Mr. X is 1.57 multiplied by 1, which will be 1.57 meter. So it is very easy to find the distance covered on a circular track. Now let us talk about the displacement. As we know, the displacement is a straight distance, or the displacement is the direct distance or the minimum distance. So the direct distance from A to B is here. This is called the direct distance. Okay, how can we find that? It's very easy to find, because this BOA is a right angle triangle and two sides of that right angle triangle is already given, which are r and r. So if we use the Pythagoras as we already used earlier, so this is r, then this will be root 2r. So the displacement of Mr. X during A to B is root 2r. If the radius is 1 meter, then root 2 meter is the displacement of Mr. X during A to B. Now suppose Mr. X moved from B to C. So here he is on C. So let us talk about the total journey. The total journey is from A to B and then B to C. So the distance covered by Mr. X is from A to B to C is the length of the arc. Or in other words, you can also say that this is a semicircle, which is half of whole circle. Now we know the circumference of the circle, which is the total length of the circle. Now the total length of the circle is 2 pi r. Then what will be the half length of the circle? It will be obvious, 2 pi r by 2, that will be pi r. So the distance covered is d, which is equal to pi multiplied by r. Okay, how? Listen, there are two ways to find it. One of them is very simple. If you just take the circumference of whole circle is 2 pi r, then Mr. X moved from A to C, which is the semicircle or the half circle. So the distance covered by Mr. X will be the half of 2 pi r, which is pi r. In another way, when he moved from A to B, the distance covered by him is pi by 2 into r. So if you double it, you will get the total distance, which is A to C, and that is pi by 2r plus pi by 2r, that will be pi r. So this is it, friends. This is about the distance. Now let us talk about the displacement. Initial position of Mr. X was A and the final position is C. So the direct distance between A to C, you can see here it is. This is called the displacement, and this is a diameter, which is double of the radius. So it is r plus r. So displacement X is 2r, 2 times the radius. So this is it. It's very simple. The distance is half of the circle and the displacement is the diameter. Now Mr. X moved to D. So here we are having another journey, which is A to B to C to D. Now the distance covered by Mr. X during this is what? Distance is just an arc. Now arc from A to D, that will cover this angle. Now this is 90, 90, 90. So 3 times 90, that will be equal to 270. As the length of the arc is angle multiplied by the radius, this is 270 in degree. So we need to convert it in radian. So we will multiply it by pi by 180. We will get 93s are 92s are. So it will be 3 pi by 2. And we need to multiply to find the arc. We need to multiply by the radius. So it is r. So angle multiplied by the radius, that will give the length of the arc, that is the distance. So the distance will be 3 pi by 2 multiplied by r. If I want to find the distance, I will substitute the value of pi and r, I will get the distance. So this is again very simple. You need to take whole angle multiplied by the radius, that will give us the distance. Okay, what about the displacement? Again, the displacement is a direct distance from A to D, because he moved from A to B to C to D. So the initial position is A and the final one is D. So we need to take the direct distance, which is here. So again, it will be a right angle triangle. This is r, this is r. So the displacement comes here is root 2r. So in this case also, the displacement is root 2r. If I substitute the value of r, I will get the displacement. Now Mr. X moved from D to A and came back on the original position again. So let us talk about this journey. This is a whole circle. So he completed whole circle during his journey. So I will write, it will be A to B to C to D to again A. As he completed a whole circle, so the distance covered by Mr. X, that will be the circumference of the circle. And you know the circumference of the circle is what? 2 pi r. So this will be the distance covered by Mr. X. And what about displacement? Mr. X came back on the original position. We already know that if any object comes back on the original position when he started, so its displacement will become 0, because he is on the original position. That's why its displacement is equivalent to 0. Now these all are the very famous angles like 90, 180, 270, 360. What if Mr. X moved on some different kind of angle? Let us suppose that he moved from A to point P, which is somewhere here. So he moved from A to point P. So here he is, and between these two there is of 60-degree angle. So friends, this is very interesting. I need to find the distance covered by Mr. X during A to P. So my journey is from A to P. Let us discuss this. The distance is equivalent to angle multiplied by the radius, as we all know. So what is the angle out here? It's 60. So we need to convert it in radians. So it is pi by 180 and we need to multiply it by radius. So this will be 60 3s are 180. I will get pi by 3 multiplied by r. So that is the distance covered by Mr. X, which was very easy. Now let us talk about the displacement. Displacement is the direct distance between A and P, and that will be here. Now, as you know, this is also radius, so its length is r. It is also radius, so its length is r. So this will be the triangle AOP. That will be equilateral triangle. In case of equilateral triangle, all three sides will be same. Because this angle is 60, this is r, so the opposite angle will also be 60, 60. So it will be an equilateral triangle. So this is r, then this will also be r. The displacement of AP or the Mr. X during this particular journey is r. So this is it, friend. You can find distance and displacement on a circular track using two different ideas. One, the distance is equal to the length of the arc, and length of the arc is equivalent to angle multiplied by radius. And displacement is a direct distance. Using geometry, you will able to find displacement. So this is the third idea to find distance and displacement, and that is according to the directions. We are taking in 2 dimensions, so we will have different 4 dimensions, and they will be on 2 different axes like x and y. So I have taken 4 directions as given in the diagram. Let us take an issue. Suppose Mr. X is on point A. He just moved in north direction up to 5 kilometers. So which one is the north direction? You can see upward. So I need to take an upward arrow. I will suppose it will be of 5 kilometers. So Mr. X is here and he is at point B, and that is 5 kilometer distance. Then he moved eastward 3 kilometers. So Mr. X moved eastward. East is in that direction, you can see that. So Mr. X moved from B to eastward, that is here. This is 3 kilometer. We need to take care that the 3 kilometer arrow will be less than the 5 kilometer arrow. So in this case, find the distance covered. It is very simple. It is 5 plus 3, so the distance covered is 8 kilometer. Okay, what about the displacement? Suppose the last point Mr. X is on is C. So the displacement is a direct distance, or you can say it is the minimum possible distance. So the direct distance between these 2 points I will draw like this. So this AC will give me the displacement. So this is a right angle triangle, and if I want to find this, I need to use the Pythagoras Theorem, which is the square of 5, which is 25, plus square of 3, which is 9. So it will be square of 34 kilometer. That will be the displacement of Mr. X. So you can say that whenever object moving in different direction, you will be able to find this distance and displacement by this particular way. Now let us take another problem. Now Mr. X is somewhere on point P. Then he moved northward up to 10 kilometers. So from P to northward. So here it is point Q, which is at 10 kilometer. Then he moved eastward up to 4 kilometer. So eastward up to 4 kilometer. This is R. This is 4 kilometer. Then he moved 7 kilometers southward. So from R he moved southward. You can see that south direction is downward. So he moved 7 kilometer. 7 is less than 10. So I will draw a line which is less than 10. So it is 7 kilometer. Now I want to find the distance covered by Mr. X. It is very simple. Suppose this point is S. So from P to S, it is 10 plus 4 plus 7. It is 14 plus 7, which is 21. So the distance covered is 21 kilometer. Okay, what about the displacement? Displacement is direct distance, as you know. So the displacement is the direct distance from P to S, and here it is. To find that, I will use a simple geometry. I will draw a perpendicular on PQ, as you can see. So that distance 4 kilometer will be here also. It is 4 kilometer. Let us say this point is M. So S to M is 4 kilometer because they will be same. Now this is 7, so Q to M will be also 7 kilometer. Now this whole PQ is 10 and Q to M is 7, so the remaining part M to P will be 3 kilometer. It's very simple. So the displacement is PS. Here it is Pythagorean right angle triangle. So this is 4, this is 3, then the hypotenuse will be 5 kilometer. So you can see the displacement covered by Mr. X is 5 kilometer. So it's very easy to find actually. You just need to use some geometrical ideas to find the distance and displacement in case of directions. Hi friends, this is Chetan. Thanks for watching the video. I hope you liked it. The video is based on the NCERT textbook of 11-12 Science Physics. I'm soon going to upload the exercises and the solutions related with this video. Keep in touch. If you like the video, then please subscribe and like the channel. Thank you.